Okay, so with this one, we want to express this as a ratio of integers. A ratio of integers is where you have a number over a number like that. And we know that this is going to be a series, an infinite series, because we have a bar here with some value here in decimal places. So let's go ahead and try to turn this into a series and see what kind of series we get. So this goes to infinity, and we like to start our stuff at 1, n equals 1. Well, let's first rewrite this into a form so that we can notice its pattern. So we have 2.516 plus 2.000516 plus 2.000000516, and so on. That's what it's going to look like. So what could we do with that? What could we do with something like this? What is it that, how much are we shifting? We seem to be shifting by 3 places. By 3 places. 3 decimal places. And each time it's 3 more, and 3 more, and 3 more, right? So that's telling us that 3 decimal places is our common ratio. 3 decimal places is going to be our common ratio, and this is geometric. This is geometric because each time it's 3 more, then 3 more, then 3 more. When we have something geometric, that means we're taking this to an exponent. Our exponent is not going to be n, it's going to be n minus 1 because we started it at 1. If we had started at 0, we could just have n. And the reason we do this is so we could have a value here. We could start a value at which we initialize it and which is multiplied to it each time. So what would be our value? Our value would be whatever is going to be multiplied each time. And it seems that's 516. 0.516. Because if we plug in 1 over there, that would give us, this would go away, and so this would become a 1, in other words. So we want our first term to be our first thing. And we bring out the 2 and add that. Because the 2 has nothing to do with the series. The 2 is not really being multiplied, it's not being anything. It's just something that we add after the fact to the actual thing, which is repeating forever. This is repeating forever, the 0.516. The 2 is not repeating forever. The 2, if we had like 500 here, whatever number, that's just being added, right? That has nothing to do unless it had, unless it was on this side and had a bar up there. So even if something didn't have a bar, even if something was a decimal, like say we had it like this, we would be adding 0.2. We would be adding 0.2 to this series. So what really matters is only what's after the decimal point, which has a bar. If it has a bar, that's what is going to be sort of repeating in that way. So now we have this thing. It's obviously going to converge because we have a geometric series, and this is r, and r is less than 1. So what does it converge to? It converges to a over 1 minus r. That's just the formula that we have. R is our common ratio, which is this, 0.001, and a is what we get with our first term. So if our first term we know is going to be when we plug in n equals 1. So we plug in n equals 1 here, we would have this be 0, this would go to 1, and so we would be left with this. 0.516 is A. At this point, you could use a calculator and just plug that in, and you would eventually get this right here. What they really care about is that you get these initial steps, that you get the idea of this being an infinite series which converges. That's all a repeating number situation there really is.